So, section 422, we get to look at some more systems of equations to be able to solve some problems. So we're going to act like we are toy makers and, you know, actually put together a real life-ish type problem. So the Toyum builds toy cars and trucks. So we're going to build some toy cars and trucks today. In order to meet, to build each car takes 4 wheels, 2 seats, and 1 gas tank. And then we're also building trucks, and to make those trucks, you have to have 6 wheels, 1 seat, and 3 gas tanks. That's the only way you can build these at the Toyum toy factory, right? And then his stack room has 36 wheels, 14 seats, and 15 gas tanks. So that's what's in the storeroom. So that's the maximum amount of supplies that you have in order to build these cute little cars and trucks. So they're trying to decide how many cars and how many trucks that they can build with the largest amount to make the most amount of money, because isn't that what every business's prerogative is, right? How to produce to make the most amount of profit. So we need to go through and come up with some of our different options, like how many cars and how many trucks can he build? So the first thing they want us to do is we're going to label cars and trucks. So I don't know, let's say that X equals cars. And what do you think Y is going to equal? Trucks.
When you put like X equals 4, well no, because how would you label like 4? I can't see that part.
I know, yeah.
Whatever's 2, whatever's 2.
Right, yep, yeah. So we're going to sit there and try and see if we can list out like coordinate pairs, like X's and Y's, because we are going to make both cars and trucks. So we could make nothing at all. So if we think of our coordinate pair, we could make 0 cars and 0 trucks, right? Could we make 0 cars and 1 truck off of the supplies that we have? Yeah, we have enough to make 1 car, right? Do we have enough supplies to make, oh sorry, that was a truck, wasn't it? 0 cars and 2 trucks, right? Could we do 0 cars and 3 trucks? Do we have enough for 3 trucks? You think so? I think so. Yep. Yep, we're still good so far, right? Could we do 0 cars and 4 trucks? So to make 4 trucks, we would need, what, 24 wheels? I think we're good on that, right? We would need 4 seats, and we would need 12 gas tanks. We good with that? Yep. Could we make 5? No. Why couldn't we make 5? I think we can do 5. Nope, you're good, right? So we could do 5, right? Can't make 6 though, right? Right, exactly. We don't have enough gas tanks to make 6, right? Then we can sit there and start getting a little bit more spicy. Could we make 1 car and 1 truck? Right? So you can go through and you can keep listing out all of these different possibilities. Could we make 1 car and 2 trucks? We probably have enough, right? So I'm going to spare you guys a little bit of pain, if you guys trust me. I think these are all the different possibilities. Right. Now, let me move this guy down a little bit. Okay. Remember we did X, Y. So the first one was cars and then trucks, right? So we could go through our little list and we can see. So like this one right here is telling me I can build 4 cars and 1 truck, right? You guys believe me? You trust me on all of these? Do you want to go through and figure and see if they're all true?
Yes.
Yeah, all right, you go ahead and do that and I'll wait. Let me know when you're ready.
So, if we're like doing this problem by ourselves, is it gonna give us those?
No, you'd have to come up with them.
All of them?
All of them. It's not that many.
Isn't there going to be like an equation that you're going to show us?
Oh, an equation. That might help a little bit too, right? Yeah, and then you wouldn't have to plot them all.
Would it be like the
We're getting there, right? So then, so we found out all the possibilities. So I said to make a list of all the possible combinations. Did we make a list of all the possible combinations? Right. Now they want us to plot the numbers in the first quadrant of a graph. Right? Why do you think we would only use the first quadrant of the graph?
because we can't have the negatives.
Can't have any negatives. Yeah. So anytime we make a graph, we need to label our axes. So what do we want to name this one down here?
No, not like that. Okay, I gotcha.
Starts with a C.
Cars.
Cars. Right? This would be our cars. And what one would this be?
Trucks.
Trucks, right? Remember our Y was our trucks. So we can label this one trucks. Then you got, 1, 2, 3, 4, 5, 6, 7, 8, right? 1, 2, 3, 4, 5, 6, 7, 8, right? And then they actually want us to go through and they want us to plot all of these points. So, you got one at 0, 0. You got one at 0, 1, 0, 2. You got all of these points going on. What do you think you're going to do with these points?
Connect.
Are we going to connect them?
Probably.
Maybe. So I'm going to draw a bigger representation over here for a second. Let's see, that's 1, 1. Okay, I'm doing a really bad job today. I got a little eraser. Say I filled in that point, and then let's say I filled in the point 2, 2. And I connected those points, right? When I connect those points, what is that connection doing when I fill in that line? It's saying that every point that's on this line is an option or a solution, right? So technically then, like right here, 1, 1 would be a solution. Well, I could have 1 car and 1 truck. But what would this guy like right here be? What would that point be? What's my x coordinate right there?
2. Oh, sorry.
1.5.
1.5.
And then what would my y value be? 1.5. So can you build 1.5 cars and 1.5 trucks?
No, not really.
Well, you could attempt to, but it really wouldn't work, right? You couldn't sell 1.5 trucks, right? So these are all like discrete points. So when it comes to plotting all of them, guess what you're gonna do? You're not gonna connect them. So you have all of these points through all of here, and it would look like that.
So like connect or?
Pardon me?
Never mind.
So those are all of the possibilities of when it comes to figuring out cars and trucks. Sound good? All right. So now they want us to take all of that information that we have, and Odo wants to make as much profit as possible. So we're going to use all of that list from that previous problem, all of these guys, or our graph, if we want to use our graph. to find which combination of cars and trucks make the most profit based on the information below. So for letter A, which of Otto's options gives him the greatest profit if he makes $1 on each car and $1 on each truck he sells? So we want to make $1 on each.
We probably just do cars, right, 'cause it gets less stuff. Can you make more cars than trucks?
It would be 3 cars and 4 trucks.
All right, so we got $1 for each. Yeah. So which one did you say?
3 cars and 4 trucks. 5 trucks.
3 cars and 5 trucks? Can we make 3 cars and 5 trucks?
No.
No.
It'd have to be the 6 and the 2, or 6 cars and 2 trucks.
Oh, 6 cars and 2 trucks?
We still can't do that.
We can't do, yeah.
Wait.
Yeah, we can. Yep, we can do 6 cars and 2 trucks. Yep.
My bad.
So if it's $1 a piece, like ultimately we're just really kind of looking through to find where we're making the most, right? Because it's $1 for each. So we're just adding our cars and our trucks together until we find which one gives us the greatest value, and that's 6 and 2, right? It's going to give us a profit of how much money?
$8.
Yep. $8.
That is not very
Right. Uh-oh, I'm getting laggy. I hope this thing doesn't stop. All right. So now let's change it up a little bit. And they want, so the market has changed. Go figure. It's been changing daily for us this year. Now Otto wants to make $2 for each truck, but only $1 for each car. What's the best choice? So now for our car, we're still going to get $1 profit, but for our trucks, we're going to make a $2 profit. So sometimes it's just kind of like trial and error. So pick any option. What do we want to start with?
0 and 5.
0 and 5. So if I start with 0 and 5, I'm going to make, what, $10 in profit?
Yep.
All right. So let's compare that to another point or another option and see what we got going on. Anybody got another number they wanna, another option they wanna try?
Uh, 3 and 4.
3 and 4. Let's try 3 and 4. So if I try 3 and 4, so my cars I'm only gonna make $1 profit, so that's gonna give me $3. 4 trucks is gonna give me 8, and that's gonna give me how much money? 11. So I think we want to try and keep our number of trucks to the highest, right? Is there any other one we want to try? I don't think so, right? Because this gave us the most amount of trucks, which gave us $10. So like, let's try dropping it down 1 and adding some cars and see what happens. So we dropped our trucks down to 4 and our car was at 3. That gave us $11. So I don't see any other option where we still have our 4 trucks and our number of cars increase. So I think we're kind of good. You guys good? All right. But do we really always want to sit around and look at points on the graph and all of these and trial and error and picking and choosing? No. So somebody alluded to it a little while ago. We can come up with some equations, can't we? So there were 3 constraints that we had to deal with when it came to building our cars and our trucks. And those constraints are those little factors that we have to deal with. That's going to limit. So what do you think our 3 constraints are going to be? The number of wheels, the number of seats, and the number of gas tanks, right? So those are like our constraints that we got going on. Whoops. So we want to be able to come up with 3 inequalities that take those 3 constraints and what the values are on all of those. So we have to make a formula that talks about the number of wheels that we have. We have to come up with an inequality regarding the number of seats, an inequality regarding the number of gas tanks, right? So I went ahead, and when they were originally giving us all of the constraints about how many seats, wheels, and tanks it takes to build and all of that good stuff, I just kind of copied and pasted it down here. So let's talk about our wheels. So in order to make a car, how many wheels do we need?
4 wheels.
4 wheels, right? And so since we're talking about the car, that's going to be our x. So we'd have 4x. Right? Plus our truck wheels. And how many wheels do we need for a truck? 6. Right? For every truck that we build. So y. And how many wheels are we working with altogether in the factory? 36. Okay. So now we got to figure out what inequality we're going to use. Okay. Can we use more than 36 wheels? No, because we don't have any more, right? Could we use exactly 36?
Yes.
Yeah. So the piece on the left is telling us how many we need or what we're going to use.
So less than or equal to?
Yep, less than or equal to 36. And then we're going to try and do it for our seats. Okay. How many seats in a car?
2.
2, yeah. So 2x plus how many for our truck?
1.
1. So if it makes you warm and fuzzy, put a 1 in front, or you can just leave it as a y. How many seats do we have available?
14.
14. Okay. Can we use more than 14 in our construction? No, so it's got to be less than. Could it equal 14? Yeah, it could equal 14. We would just deplete our supply. Right? And last but not least, gas tanks. How many gas tanks for our car?
1.
1. So, like I said, if it keeps you warm and fuzzy, put a 1 in front of the x. Plus our gas tanks for our truck. Our truck is going to take how many?
3.
Yep, 3y. That's got to be less than or equal to
15.
15. Right? So guess what we're going to do with these 3 equations?
Solve them.
Yeah, and we're probably going to solve them by using, what's that thing called on there? Starts with a D? DES, DES? Some Desmos? Yep, or if you have a graphing calculator, you can use your graphing calculator, right? So we all know how to get to Desmos, right? Oh, let me slide this guy. Woo. Man, that's close enough. All right. So our first equation was what? 4x plus 6y. And if we do our little keyboard, we can find our less than or equal than symbol. 36. Right? Slide this. Oh, I'm gonna make him a little bigger. Can I make this guy smaller? Ooh, oh, look at this. We're moving now, right? And then we can throw in our next equation, because these are a system. Systems is just more than one equation. What do we have? 2x plus y less than or equal to 14. So that would be that one. Right? And then our last one was 1x plus 3y is less than or equal to 15. And that one's our gas tanks. So we can look at these individually, maybe, right? Bless you. Yep. So the number of wheels. So we just have to be sometimes a little smarter than when it comes to our graph. Because remember when we did this originally, we had all the discrete points that were on our graph, right? On Desmos, it doesn't show us like the discrete. It just does it because it doesn't know we're looking at car wheels. It's just looking at an equation. So technically when it comes to this, like, these are all solutions that are shaded underneath, but we can't use all of those, right? We can't use those halves. Can we use these negatives? No, right? Because with those negatives, we can't have negative wheels. So then, if we just think of the wheels, these were all the possible or the feasible solutions for the number of wheels. And then when we add this next graph on there, this was the number of seats, right? So if we only looked at the seats all by itself, we're going to have a different feasible area than what we are if we put both of those together. So we're looking for that area where they're both shaded, right? So now this kind of technically a quadrilateral, this four-sided weird looking shape, would be all of our feasible solutions, right? And then all of a sudden we add that third component on there, that third constraint of those gas tanks. And then now it made that little area even smaller. Now we have a five-sided, we have like a pentagon, right? So we could have 0 cars and 5 trucks, right? These would be our little boundaries, right? The 3, 4, the 6, 2, right? Oh, I can get them to stay? Oh, okay. Yep, or technically, oh, I gotta throw that in there. You know, we have to have these. Oh yeah, black. I want to shade in black. That's a great color to shade in. If I put my X and Y's are greater than 0. I wonder if I can. Oh. There you go. A little bit better then. So it gets a little on the sloppy side color-wise. But we know we have 0, 0, 7, 0, 6, 2, 3, 4, and 0, 5. Oops, that one went away. I don't know how to get them to stay, guys. I apologize. There we go. Hey! I did it. Hey, man. It doesn't take much to entertain me. So, because that is where all of those constraints... All right, I lied. Should be that one, right? Oh, no, it's good. I got you. It's this color. Yep. So those are our little constraints. So anything within those areas, that feasible area would give us solutions that would give us be able to make our vehicles. And we already talked about, what is it, letter C, when it comes to our region. Why X and Y have to be greater than 0, why they can't be negative, because we know we can't have negative wheels, negative seats, negative gas tanks, right? Sound good?
Yeah.